In this problem, we are asked to make a 10% acid solution. A chemist is going to mix a 20% acid solution with a 5% acid solution, and we want to know how much of each they need to mix together in order to make 20 milliliters of a 10% acid solution. One way I could approach this problem is to draw a picture. I have these two containers, one a 20% acid solution and the other a 5% acid solution. A 20% acid solution means that 20% of the amount of liquid is going to be pure acid and 80% is going to be water. Likewise, a 5% acid solution is 5% pure acid and 95% water. When I add these together or mix them together, what I want is my container to be a 10% acid solution and have 20 milliliters of solution. Therefore, if I look at this, 10% of my 20 milliliters is pure acid. Or, likewise, 10% of 20 is equal to 2. I have 2 milliliters of pure acid in my final mixture. Now I'm ready to find two equations that would help me solve this task. I'm going to define some variables. I'm going to let x equal the number of milliliters of my 20% acid solution. And I'm going to let y be the amount that I add, or the number of milliliters, of my 5% acid solution. So one equation that I have is I know that if I take the amount of my 20% solution and add that to the amount of my 5% solution, I am going to get a total of 20 milliliters. My second equation that I'm going to write is going to be based off of the amount of acid in each one of the containers. So if I look at my first container, 20% of the total amount is going to be pure acid. So the amount of pure acid in my first container is 20% of x. 20% of x can be written as 0.2 times x. Again, that represents the amount of pure acid in my 20% acid solution container. Likewise, I'm going to add that to the amount of pure acid in my second container. And my second container is a 5% acid solution, so the amount of pure acid is 0.05 times y, or 5% of y. When I add these two together or pour the mixtures together, the amount of pure acid is going to be found by the sum of 20% of x plus 5% of y. And I already know that since my final solution is a 10% acid solution and has 20 milliliters, that the amount of pure acid is going to be 10% of 20, which we found to be 2. Now I have two equations. To solve this system of linear equations, I'm going to use substitution. I'm going to rewrite my first equation in terms of y. So my equation is x plus y is equal to 20. So if I subtract y from both sides, I get y is equal to 20 minus x. I'm going to use this equation and substitute it into my second equation. So I have 20% of x, or 0.2 times x, plus 5% of y, or 0.05 times y, and y can be expressed as 20 milliliters minus x. That's going to be equal to the amount of pure acid in my final container, which is 10% of 20, or 2 milliliters. I can use a distributive property to simplify that left-hand side. I have 0.2x plus taking 5% of 20, or multiplying 0.05 times 20 would give me 1, and taking 0.05 times a negative x would give me a minus 0.05x, is still equivalent to 2. Combining like terms, I have 0.2x minus 0.05x, which gives me 0.15x plus 1 is equal to 2. Subtracting 1 from both sides, I get 0.15x is equal to 1. Dividing both sides by 0.15 will allow me to find the amount in milliliters of our 20% acid solution. Therefore, x is equal to 1 divided by 0.15, giving us a value of x of 6.6 repeating, and that would be in milliliters. Well, let's see. We want to change 0.6 repeating into a fraction. We know that 0.3 repeating, or 0.33333, is equivalent to 1/3. So 0.6 repeating must be equivalent to 2/3. Therefore, x, or the amount of 20% acid solution, is 6 2/3 milliliters. Since we know there's 6 2/3 milliliter of our 20% acid solution, we now have to find the amount of our 5% acid solution. We know the amount of the 5% solution is going to be given by y is equal to 20 minus 6 2/3. 20 minus 6 2/3 gives us 13 1/3 milliliters. And this is the amount of our 5% solution.